Let's continue with a few more examples. The next one, which I've labeled number 6, again has a couple of premises that are if-then statements. So remember, if-then means I have an inner set and an outer set, one set inside the other. In this first example, if it is a bird, then it's an animal. The inner set would be birds. The outer set with this first premise would be animals. The next premise says if it is an animal, then it is alive. So the animal set, which we already have, needs to be inside the alive set. So I need to draw an even bigger circle and label it alive and make it entirely surround the animal set. Now we can look at the conclusion. The conclusion says if it is alive, then it is a bird. An if-then statement always means that the first set has to be inside the second set. Is alive inside birds? No. When we look at this carefully, birds are inside the alive set, not the other way around. So this statement right here is if it's alive, then it's a bird. That is a false statement based on what you see from the premises. So this conclusion does not work. It is invalid. I have two more examples on this slide. They both coincidentally have the same two premises. So problem 6 and problem 8, same premises. So I'm just going to use one picture to demonstrate for both of these. The first premise in each one of these says all carnations have a nice, and I put scent there, but it's supposed to actually be scent as in what you smell. So a nice aroma, you might say. So I apologize. This may have been the program trying to guess what I wanted to write, and I didn't catch it, but it should have been scent in both of these cases. All of the places where I have scent, it should be scent with a C. So all carnations have a nice scent. So we have the set of carnations inside the set of nice scents. There's a lot of words that start with S there. So the first premise, all carnations have a nice scent, relate to the carnations being a circle inside the set of nice scents. All always means you have one set inside the other. Now the second premise is a little different though. It doesn't say all, it says some. When we use the word some and draw it out with the sets, some means that the two sets are overlapping. So the two sets in this example are flowers and carnations. We've already drawn carnations, so then we have to draw flowers. Now the set of flowers is going to overlap with carnations. And one way to overlap with carnations, and I'll label this flowers before I go any further, is to actually have it still be entirely within the nice set category. But I want to point out that there is another way you could do that. This set could overlap and go outside of the nice scent category. We don't really know. It may or may not. All that some says is that some, in this context, means the flower set overlaps with the carnation set. It's not telling us how the flower set overlaps with the nice scents. We know that it has to be partly in the nice scents set because it has to do with overlapping with carnations, and carnations are in there. But one thing to be aware of is that we don't know how far and how large that set goes. Does it entirely stay within the nice scents? Or does the set of flowers expand out beyond nice scents? So that's our picture. Let's look at the two conclusions. So the first conclusion here in problem 7 says that some flowers have a nice scent. Well, I think we can definitely say that's valid because there is a location here where flowers overlap with carnations, and we know that carnations have a nice scent. And since carnations are flowers, we know that carnations, according to the first premise, have a nice scent, then this conclusion would be valid. In the next example, though, where I change the conclusion is thus all flowers have a nice scent. Well, remember one of the things we said over here is we don't know how large that flower set is. Does it stay within the nice scent set, or does it expand out beyond that nice scent set? Boy, there's a lot of S's here. Sorry about that. So in this case, because we don't know whether it entirely stays in there, we have to say that this is an invalid argument. Once again, invalid means is the situation where you're not sure if that is going to be true or not. You don't have enough information from the premises to back up the conclusion. So if you don't have enough information to back it up, if it may or may not be true, that's when we have an invalid statement.